Welcome, welcome, New Horizons students. My name is Sandra Hindo. I'm a Lean Six Sigma and ITIL technical instructor at New Horizons. I want you to sit back and imagine this scenario for a second. You were just hired as an external consultant at a major tech company. And all of a sudden, you find yourself stuck in an elevator with the CEO. The CEO looks at you and says, hello, welcome. I heard you're the new Lean Six Sigma professional. What are you working on? And your mind goes into a daze. I only have 30 seconds in the elevator with the CEO of this tech company. What am I going to tell him or her? My friends, you can easily justify the importance of your Lean Six Sigma project and also justify why they hired you as a Lean Six Sigma practitioner via the 30-second Lean Six Sigma elevator pitch, aka your problem statement. In this Lean Six Sigma tips and tricks video, I'm going to show you how easy you can create an effective Lean Six Sigma elevator pitch, aka your problem statement, how to never again fear how easy it is to conduct a statistical test with the most common one that you're probably going to utilize as a practitioner, which is a two-sample t-test. And lastly, how to write a concise results statement that everyone is going to appreciate because it's easy to understand. Let's get to it. Remember, y'all, you have 30 seconds to justify not only the importance of your project, but your existence, why they hired you in your first place. Let's get to it. You can easily achieve this via the problem statement. My friends, this is at the heart of every Lean Six Sigma project that you're going to supervise and manage. This problem statement needs to be tight. What are the 5 elements contained within a problem statement? The first one is your baseline. Where are you at this moment in terms of the number of defects? So in this example, currently in the tech manufacturing company, there are 100 defective cell phones per day. That is your baseline, with a goal of 5 per day. So the goal, which is the second element, is 5. And then you have your gap. Your gap is simply baseline number minus your goal number. So 100, where you are at this moment, minus 5, where you want to be, that's 95. Your gap equals 95. How long is it going to achieve? How long is it going to take you to go from 100 defective cell phones per day to 5? Well, as a team, we determined it was going to take 4 months. And then lastly, you have your COPQ, which stands for the cost of poor quality. How much is it going to cost your company for not removing those 95 defective cell phones per day, at staying at the baseline, which is 100 defective cell phones per day? The most effective way to incorporate the COPQ, that basically by telling your audience that if we get rid of these 95, if we really go from 100 to 5, how much company cost savings there will be. So for the fun of it, let's put these 5 elements together and you're officially stuck in the elevator with the CEO. Here it goes. Hello. Hi, Sandra. I heard that you're the new external consultant and you're working on a Lean Six Sigma project. Can you tell me about it? Well, CEO, currently in the tech manufacturing company, there are 100 defective cell phones per day, baseline, with a goal of 5 per day. The goal of this project is to reduce the gap, that is, the 95 defective cell phones per day, in 4 months, saving the company $23,750 per day and $6.1 million annually. You stop right there. Don't say anything else. He's going to be impressed. If he's really interested, he's going to say, hey, do you have your 25 to 45 page Lean Six Sigma report? I want to see exactly how you save the company this much money. Or if he's pressed for time, he's going to ask you for the 1 to 2 page executive summary, which is a condensed version of that lengthy Lean Six Sigma report. There you have it, y'all. If you're ever in a situation where you're confused, you're not sure how to answer what your Lean Six Sigma project is about, go back to your beacon of light. And that beacon of light, friends, is your problem statement. Every Lean Six Sigma report, the intro starts with a problem statement. Your executive summary will be introduced via the problem statement. When you're doing your progress PowerPoint presentations for the company and the end of project presentation for your company, you're going to start it and conclude it with your problem statement. Don't worry too much about making this perfect from the get-go. You were hired to be a Lean Six Sigma practitioner. You're going to be working with subject matter experts, the SMEs, and identifying those key primary and secondary metrics that are going to be the focus for your project. Your SMEs, they're the ones that are working the processes day in and day out. And we're going to brainstorm at the very beginning, maybe a multitude of quality problems they want to tackle. But from those many, we get to a select few. And then the 1 or 2 that are going to be the primary issues that we want this specific Lean Six Sigma project to focus on. Now, in this fun, fictitious example, it is the defective cell phones that come down the production line per day. So then now that I've showed you how easy you can achieve the Lean Six Sigma elevator pitch via problem statements, I like to now show you the most common statistical analyses in the world of Lean Six Sigma. The most common test used, and y'all know there's a plethora of choices. There's a one-sample t-test, two-sample t-test, ANOVA, Mann-Whitney, chi-square contingency tables. There's a lot. But my friends, if you guys can stay with me for the next few minutes and master the two-sample t-test, you're going to be way ahead of the competition, because a lot of process improvement specialists, they don't even want to touch statistics because statistics has always been difficult for them. But I'm going to demystify and show you how easy it is to conduct a two-sample t-test via the statistical software package, Sigma Excel. So let's get to it. Again, this is the most common one, so take advantage of this video and master it Now, here it goes. A two-sample t-test answers the question, is there a statistical significant difference in the number of defects before and after your improvement plan? Your goal as a Lean Six Sigma practitioner is to be able to state there is a statistical significant difference in the number of defects before and after the improvement plan. Why? This means your improvement plan was effective in reducing the amount of defects. When something is statistical significant, it means the difference before and after the improvement plan did not occur by chance, luck, or was a fluke. It proves this difference occurred because of your improvement plan, a direct result of the changes you made to the process. If you can follow a few simple tests and follow a few universal rules, you too can effectively conduct a two-sample t-test and confidently report the results of your study. A few simple steps that we're going to be doing together today. Remember, the test is called a two-sample t-test. The two samples means there's going to simply be two columns created in Sigma Excel. The first column is the number of defective cell phones before the improvement plan. This is your baseline. And then your second column is going to be the number of defective cell phones after the improvement plan. You have two samples, two columns, before and after your improvement plan. And what's smack dab in the middle? What's smack dab in the middle is your improvement plan. You, the Lean Six Sigma practitioner, work together with the SMEs, aka subject matter experts, as a team to identify bottlenecks, aka constraints, and ways in which to clean, standardize, and optimize a given process. Your goal for the improvement plan is to minimize the variation found within the process and ultimately reduce the number of defects found within the process. Y'all, there's several Lean Six Sigma tools available to you to achieve your goals. Your tool belt is going to be heavy. It's going to wear you down. So you must be choosy. You must ask yourself, what tools are a must to achieve my problem statement? There's tons and tons of tests. This is just scratching the surface of the tools available to you. Let's go back up here. Your first column, you're going to be inserting your data prior to implementing any improvement plan. And after you have this column, you're going to actually implement your improvement plan. I've seen it anywhere from 30 days of training your workforce on the new processes. And I've seen it anywhere from 60 days, 90 days. Implementing your improvement plan and how quickly you go about and how strategically you go about training your employees on the new processes, on the optimized, standardized processes, it's going to differ anywhere from 30, maybe 60 days, even 90 days. But once you're done implementing those action plans, then once again, you're going to record after the improvement plan number of defective cell phones. We're hoping to see a difference, but let's open the statistical software package and figure out for sure. First thing I'm going to do is just simply highlight my first column, starting from the very beginning, and we're going to take it one step at a time. The statistical software package is called Sigma Excel. It's an add-on to Excel. I have the add-on right here, Sigma Excel. My first column, we're going to call it Before Improvement Plan, number of defects. That looks good. Remember, what does the IP stand for? Improvement plan. This is your baseline, my friends. Before improvement plan, number of defects. We can also insert baseline if it helps you out. That does help out my students in keeping it a little more clear in case you get lost around during the process. This one, we're going to be calling it After the Improvement Plan, number of defects. And keep it clean, let's call this goals. It's important that you do take this first step in labeling your columns. And now all I'm doing, copying and pasting numbers. Let's see. So let me explain this to you, okay? Because we're doing it step by step. This is a manufacturing line. They're producing what? Cell phones. It's a fun scenario to work with. On day one, the production line is producing 50 defective cell phones. Day two, 65 defective cell phones. Day three, 47. And they're recording a multitude of days all the way down to day 20. So day 20, they produce 71, day 19, 70, and so forth. So basically, they're recording the number of defective cell phones per day over a period of 20 days. You could have done it over a period of 30 days, 45 days, up to your team. And then you spend 30 to 60 days implementing the new, improved, standardized, optimized processes. You really trained the production line on the new processes. You worked hard. After you guys work hard, you're now going to collect the after improvement plan number of defects. We're hoping these numbers are going to be lower than these. Let's keep our fingers crossed. If they're not, we went. We made some mistakes during the implementation of the improvement plan. It happens. It really does. So let me just copy and paste this. Simply, this is a two-sample t-test, which means there's two columns. Obviously, you're going to assign someone to capture this data and someone to enter it and conduct the analysis for your report. So the first step in conducting your two-sample t-test is to highlight both of your columns. You could have also pressed Control-Alt. That would have done the same thing. And now you already clicked on Sigma Excel. You go on Statistical Tools, and you choose the two-sample t-test. You definitely want to check off both of these boxes. So you want to check off the Use Data labels, which are these two here, and then the entire data table. Check these both off and press Next. These are unstacked columns because we have two numeric data columns. Numeric column number 1, numeric data column number 2. So make sure it says unstacked. And we're going to put both of these in this box. Before IP number of defects, baseline, and after the improvement plan, number of defects, the goal. Your HO is your null hypothesis. Your null hypothesis always states that there is no difference in the number of defects before and after your improvement plan, aka group 1 equals group 2 in terms of the number of defects. Your alternative, HA, is the one that always states that your before improvement plan numbers do not equal your after improvement plan numbers. Your two columns do not equal each other. Remember, as a Lean Six Sigma practitioner, what do we want? Do we want our before and after numbers to statistically equal each other? You want the numbers to be the same before and after your hard work? Or do you want the numbers to be different? Well, if I want to work more for this company, if I want to continuously be hired as a consultant for this company, I'm definitely hoping that there's going to be a huge difference before and after the improvement plan, because that proves that my improvement plan was a success, right? That here I am, I went in there, we optimized, we standardized the process, and I was effective as a facilitator. And consequentially, what's going to happen? We're going to be reducing COPQ, the cost of poor quality. And the bottom line is, every company wants to save money. So I'm hoping, and every researcher, every Lean Six Sigma practitioner wants to be able to reject the null, put a big X on the null statement, and claim the HA. Claim that the two groups do not equal each other. So I don't even touch this. This is already done for me. And then the most standardized confidence level is 95%. In simple words, the confidence level basically means how confident are you that the conclusions that you're going to be drawing about your study are accurate. And it's very standard to be at the 95% confidence level. There are, life and death situations, different scenarios. Maybe you're dealing with like drug treatment or medical devices that are going inside your body, and you want to set your confidence level higher than 95, maybe 99%. But don't worry about it. You're going to be working with those doctors and the surgeons and the medical device manufacturing company. If they want it higher at 99%, then do it 99%. They're going to direct you on that part, okay? So I don't even touch any of this other stuff. We just enter these two here, and we're going to press OK. Here it goes. From this line where it says mean, we know the number of defective cell phones before the improvement plan. It averaged what? Around 55 defective cell phones before your improvement plan. And after your improvement plan, it was 10. And we know that your N equals 20 here, 20 days that you were capturing the data, and 20 days after your IP, capturing the data. Your job is to record the mean 1, which is your average of column 1. So you're going to put down mean 1 equals 55 defective iPhones. And you're going to put mean 2, which is M2, equals 10 defective iPhones or cell phones, sorry. If you guys were just to eyeball this, y'all didn't even look at the p-value yet. All you inserted so far in your report is that M1 equals 55, M2 equals 10. Just eyeballing it, would you say that there's going to be a difference between column number 1 and column number 10? Eyeballing it? I'm going to say yes. I mean, there's 45. You just reduced it by 45 cell phones. That's really, really good. And now if some process improvement specialists are fearful of statistics, that's how far they get. They don't do any more. They just report these numbers and they stop right there. But you're watching this video. You're taking it to the next step so you can use those powerful words statistically. And to use that powerful word, all you have to do is record your p-value. And the p-value in this situation is simply 0. What does 0 mean? Well, I'm about to show you a cheat sheet. These are the universal rules that apply to all of the statistical tests that are going to be available to you. Never again do you just need to eyeball M1 and M2 and figure out if there is a difference between the two. You can statistically validate your results via the p-value. So let me now show you the cheat sheet. This cheat sheet works for all of the statistical tests. And when you're in doubt, just pull this page up. When do you reject or fail to reject the null? What was our p-value? Do you guys remember? It was 0. So in this situation, our p-value of 0 is less than 0.05. If p is less than 0.05, this means there's a statistical significant difference between your two groups. This means group 1 does not equal group 2, aka you reject your null. And as a practitioner, your goal is to reject the null and claim that there is a statistical significant difference between the two groups. I want to take you back up here and show you the last part of the tips and tricks. The last part is to input those 3 numbers and create a concise study results statement. I captured the mean 1, which is the average of column 1. I wrote down M1 equals 55, so I captured the first number. I captured the second number, M2, which is your average of column 2, equals 10. Where did I get these again? Let's remind ourselves. Column 1 averaged 55. Column 2 averaged 10. What are we looking at again? Before improvement plan number of defective cell phones and after the improvement plan number of defective cell phones. Let's put this together. And we're going to concisely write the results of our study. The Twosample Ttest resulted in a p-value of 0. Thus, there is a statistical significant difference in the number of defective cell phones before the improvement plan, M1 equals 55, and after the improvement plan, M2 equals 10. What do you guys think the CEO and your supervisor is going to think? They're going to want to ask you follow-up questions during your PowerPoint presentations, both the progress PowerPoint presentations and your end of Lean Six Sigma project presentation. How in the world did you go from 55 to 10? And then you guys can say, hey, read my entire Lean Six Sigma report where we outlined what the before improvement plan process looked like with the high-level process maps, the detailed process maps, the functional process maps. This is what it looked like before, and look at our ideal process maps. Side-by-side comparisons of those process maps, they're very, very powerful. And then you can also go into what exactly you did in that improvement plan. The more detailed your report is, the easier it's going to be for other teams to replicate your study. So even if they're working on a different process, they can read yours and gain insights how to do their projects. It's very powerful. The more detailed, the better. And at the end of the day, what does every company care about? The bottom line. So just for the fun of it, in previous classes, we looked at that gap. You went from 55 to 10. So the gap was 45 defective cell phones. We tied the 45 with the cost of poor quality, and we came up with the daily savings from eliminating those 45 defective cell phones per day, and then calculating the annual savings. And then when you're doing your presentation, they're going to say, how did you come up with these numbers? You're going to say, well, we created a COPQ team. We had the chief financial officer and the purchasing managers. He helped us with the purchasing cost, the raw costs of each defective cell phone, and we determined the COPQ per defective cell phone was $140. Well, per day, there was 45 of those. So we took 145, we multiplied it by 45, we came up with $6,525 per day in cost savings. And then we determined that our workers were working the production line 260 working days per year. We multiplied this by this, and we came up with a little over $1.6 million in cost savings annually. You explain this in your report. You explain this in your presentations if they ask for it. Get the SMEs that can give you as close as possible to accurate numbers to capture the COPQ. You even want to get the HR director involved too, right? Because if they're producing all these effective cell phones, then there's going to be a lot of rework. And then potentially you're paying your employees overtime. You want to capture all of the soft and hard costs. My friends, in today's tips and tricks video, you learned 3 things. The power of a Lean Six Sigma elevator pitch, aka easily achieved via the problem statements. 2, the most common Lean Six Sigma statistical test, the Twosample Ttest. And 3, how to write a concise result statement. Until next time, good luck on your Lean Six Sigma adventures.